Hey guys, Vladimir here with Desktop Makes. I'm gonna switch it up a little bit for you this week. I had a coworker who came to me and asked if I could CNC machine a Pinewood Derby car that his 9-year-old son modeled in Tinkercad. So after machining it for him, I decided to put together this video showing you the process I took in bringing the Tinkercad model into Fusion 360 and in preparing it using Fusion Cam to be machined. All right, let's jump right in. The model was sent to me as an STL file, so that's what I had to work with. To bring it into Fusion 360, we'll go to Insert and then down to Insert Mesh. Navigate to where you saved your STL file and then click Open, and then we'll click OK. And as you can see there, I have this surface mesh. Now, you can actually go ahead and jump into your CAM environment and create toolpaths and be able to machine this out. However, you're gonna have an easier time and more flexibility in creating those toolpaths if you first convert this into a solid. So to do that, there's actually one additional step we need to take, and that's to stop our capture of our design history. We'll go over here next to our browser or right under it where the title of our design would be. Since I haven't saved it, it just says unsaved, but I'm going to right click and go to do not capture design history and then click continue. And once I do that, if I go back to my model and right click, I'll get this new option here that'll say mesh to B-wrap. And once I click on that, it'll convert it to a solid. But before I do that, there's one important point I have to make, and I'm going to go down to properties and click on that. And that's going to show me the number of facets that I have in this design. So you'll see where it says facet counts. It says that there's 7,056. Now, the reason why that number is important is because you want to be around the 10,000 area. If you're within 10,000 facets, Fusion's generally going to have no problem in converting this. However, if you're over that, you still might be okay, but if you're way over it, then Fusion can just abort the mission. So that's an important consideration there. If you're bringing a model that's very intricate, it's got a very high facet count, it's not going to work. Now, you do have the option of bringing it into your mesh environment and reducing it, but we'll leave that for a separate tutorial. Now we'll continue where we left off, which was I right clicked and I went to mesh to B-wrap. I'm going to click on that, click OK, and it'll convert my mesh here into a solid body, as we can see here. All right, so that's that process. And then I'm just going to jump over to this other tab where I've already created the toolpath. Now, I'm just going to go over a basic overview of my approach in preparing this to be machined. I'm not going to go into great detail in my feeds and speeds and all the settings that I use. If you want a more detailed tutorial in machining an STL file, then I'm going to recommend you check out Lars Christensen. I'll actually leave a link to his tutorial below where he goes into much greater depth in machining an STL file. But for now, I'm just going to talk about my strategy here. And as you can see, I have an adaptive toolpath and a parallel toolpath. Now, the adaptive was chosen by going to 3D and then choosing my adaptive clearing. And my parallel, again, was also a 3D, and I chose parallel. Now, I'll simulate this to just show you what's going on here. I'll hit play and I'll speed this up quite a bit, and you can see that adaptive clearing just comes in and just does a good job in removing a good chunk of that wood, and then that parallel toolpath comes in and just cleans this up by going following this contour going up and down, and it actually leaves it pretty smooth. And in some cases I see where people use this parallel sort of as a semi-finishing technique. In this case with the wood, and being a Pinewood Derby car, it basically was my finishing toolpath. I used the work holding technique where I applied masking tape both to the workpiece and the table, and then used some CA glue to adhere both pieces together. I'll be cutting this on a Roland MDX 540 milling machine, and here is the adaptive clearing approach where it's using a 1/4 inch flat end mill. And after cleaning up the chips, I continue using that same end mill, but this time coming in with the parallel pass. This cleaned up that jagged stepped look and left it with a very smooth finish. Okay, here's the moment of truth where I get to see the fruits of my labor. Oh,
Is that not supposed to happen?
Yeah, it's not supposed to come off like that. Alright, let's try that one more time. Alright, I'll admit I'm still pretty new to CNC milling. My expertise is 3D printing. That's where I'm very comfortable. But I love the whole world of digital fabrication. So recently I've been quite obsessed with CNC milling. So if you have any tips or advice you'd like to give me, I'm all ears. I'd love to hear and learn from your expertise. Or if you have any questions on my technique or the workflow that I followed, leave it in the comments below. I'd be happy to go through and answer those. All right, guys, I hope you enjoyed this one, and I'll see you next week.